Alright, so this is section 7, day 1 notes. And our essential question is explain how to find the VA, HA, SA holes and the intercepts of the graph. So those will all be explained in these notes. Graphing rational functions. So when you're looking at all of these problems, if you're looking at a blank and saying, I don't know how to find the HA, which stands for horizontal asymptotes here, then that is a hint to you that you need to go back, look at your notes, because I have a how to do each one of these things in these notes for you. Okay? All right, so we've got horizontal asymptotes, which we're going to call HA for short, so you don't have to write out horizontal asymptotes every time. There's only 3 scenarios that can happen. The first one is if the degrees of the polynomials on top and bottom are the same, then your horizontal asymptote is this, y equals whatever the leading coefficient is on top over the leading coefficient on bottom. So here's an example. So in green here, we have x squared on top and x squared on bottom. So remember, the degree means the highest exponent in a polynomial. So on top and bottom, we have the same exponent. So then we ignore everything else and just look at the leading coefficients, which on top is 2 and on bottom is 3. So the horizontal asymptote is the equation y equals 2/3. Can't divide that 2/3 any further, so that's your answer. Okay? And remember, an asymptote is when it gets closer and closer. So it was when we had chapter 7. If this was my asymptote, then my exponential would get closer and closer to it, like that. Okay? So that's what we're finding for these graphs. Okay, next scenario. If the degree on the bottom is higher than the degree on the top, then the horizontal asymptote is going to be y equals 0. So here's an example. So I have x cubed on the bottom and x squared on the top. So the bottom degree is higher than the top degree. And the reason why it's 0 is because when the bottom of your denominator is increasing faster because it's cubed than the number that would be on top, when your bottom number is bigger than the top number, that means you get a decimal closer and closer to 0. So that's why if the bottom degree is higher than the top degree, your asymptote is y equals 0. So it levels off at 0. And if that's not the case, then the only other case that can happen is that the top is your higher degree than the bottom degree. So in that case, there is no horizontal asymptote. So we would just write none. Okay. So those are the how-tos on how to find your horizontal asymptote. Okay, so next, and this is put in the order that I suggest that you do it. So I suggest you find your horizontal asymptote first, then we deal with the holes and the vertical asymptotes, which is VA. Okay, so first you're going to factor all the numerators and denominators if possible, and find your restrictions. And that's actually the first and second step to both of these. So I would do the holes first and then your vertical asymptotes. If any factors with an x cancel, then that restriction is a hole. If not, if nothing cancels, then there is no holes. So that steps 3 and 4 will make more sense when we do an example. So, but the restrictions is important. That's why we did all of that practice in the first few sections where we factored everything and then stated the restrictions, and then we can't crossed out like things, like factors. We were getting ready for this. Okay, then how to find your vertical asymptote is once you found the holes, if there are any, whatever restrictions are left over, those are going to be vertical asymptotes. You can have one, you could have more than one, or it may come out to be once you cancel, nothing's left in the denominator. So if nothing's left in your restrictions, then there's no vertical asymptotes left over. Okay? So again, if you come across a blank you don't know how to fill, then come look at your notes because this is your how-to. Then we have our intercepts. So remember, your y-intercept is where it crosses the y-axis, and your x-intercept is where it crosses the x-axis. So This, I would actually want you to cross out. It says use the factored form, and let's actually cross that out and say use the original form of the equation of the function, and then cross out the before you cancel anything out part. So it's actually going to be easier and faster if you use the original factor or the original form of the function. Then you're going to plug in 0 for all the x's when you're finding the y-intercept, and then we'll solve for y. Then how to find the x-intercepts. This is the one that's better if you use the factored form of the function. I'm actually cancel right cross this part out. And then plug in 0 for y, and then you're only going to set the numerator equal to the 0. So this is the one time when you're doing x-intercepts that you care about the numerator and set it equal to 0. And then solve for x. Okay, so let's take a look. Example 1. Okay. So this is everything that we need to find. So first, I'm going to do the horizontal asymptote. So that is the one where we look at which of the three is happening. Are the degrees the same on top and bottom? Is the bottom degree bigger than the top degree? Or is the top degree bigger than the bottom degree? Well, this is x to the first on top and x squared on bottom. So your bottom degree is bigger than the top degree. So according to this, if your bottom degree is bigger than the top degree, then your HA is y equals 0. And you have to put y equals 0 because that's the equation of the horizontal line. Can't just put 0 on the line there. Okay, now to find holes, we factor the numerator and denominators if possible and find all the restrictions. That's the first and second step. So I can't factor the top, but the bottom we can factor as +4 and -2. Okay, so then for holes, we're looking to see if we can cancel anything. And there's nothing we can cancel. And if we state our restrictions, remember that's where you set the denominator equal to 0, so that'd be -4 and +2. Neither of those will be holes because we did not cancel anything out. So then for holes, I'm going to write none. On the day 2 notes is when we'll actually talk about what that means on the graph. Okay, but for now we're just doing all the calculations before we put it in the graph for the next day of notes. So then that means whatever is left over, which here what is left over is -4 and 2. That means x equals -4 is a vertical asymptote, and x equals 2 is a vertical asymptote. So this one has 2. So we would have 2 vertical lines for our asymptotes and 1 horizontal line for our asymptote. Okay, now let's look at SA, how we find the slant asymptote. Where's that? There it is. I missed that earlier. Okay, so slant asymptote means that it would be an asymptote that slanted and it gets closer and closer to. Okay, so then here, first one says if you have a horizontal asymptote, then there are no slant asymptotes. Because slant asymptotes happen when you have a higher degree on top than on bottom. And remember, that's when no horizontal asymptote occurs. So if there is a horizontal asymptote, then you're done. You could say there's no slant asymptote. But if there's not a horizontal asymptote, then there will be a slant asymptote. And we do either long division or synthetic division to find the equation of that line. Okay. So on this problem, we would say none because we had a horizontal asymptote. So remember, if you have a horizontal asymptote, you can't have a slant asymptote. Okay, now the x-intercept. Do the y-intercept over here. So the x-intercept was use the factored form of the function and plug in 0 for y and set only the numerator equal to 0 and solve for x. Okay, so then I take the numerator, which is x plus 1, set it equal to 0, solve, so x would be -1. So that's where it intercepts the x-axis, but I want you to write it as an ordered pair, so it would be -1, 0. And it's 0 for y because that's when it lands on the x-intercept or x-axis, the y is 0. Okay, now let's do the y-intercept. The y-intercept, if you use the original form of the function and plug in 0 for all the x's, it'll be easier. Okay, so that means I go back to the original, so I'd have 0 plus 1 all over 0 squared plus 2 times 0 minus 8. Well, these zeros just go away because that doesn't matter. And then you would have 1 over -8. So then as an ordered pair, that's 0, -1/8. 0 for x because when you're doing the y-intercept, that's when x is 0. And I just plugged it back into this original form. So when you do that, 0, 0, 0, because 2 times 0 is just 0, you're left with the n numbers over one top over the bottom. Okay, and that's it. On day 2 notes, you learn how to put all that in the graph and graph it. Okay, let's look at number 2, example 2. All right. So to find the horizontal asymptote first, we look at the degrees. We have an x squared and an x to the first. So when you go back, which scenario is that? That is the bottom one here where the top degree is bigger than the bottom degree, which means there's not a horizontal asymptote. So we would write none for this one this time. Okay? All right. Now, let's do the wholes. And remember, that means we have to factor everything. So we'd get 7 and 3 for this one, all over x plus 3. Restrictions are x cannot equal -3. Okay, so then we can cancel out the plus 3's. And when you can cancel out, that creates a whole. So that means that this x equals -3 is a whole. And then I'm going to cross it out because I've already used it. Since there are no other restrictions left, notice there's nothing left in the denominator after you canceled the x plus 3's out. So that means that there's no vertical asymptotes because there's no other restrictions left over to become the vertical asymptotes. So the restrictions that we used to find before would either act as a whole or they're going to be a vertical asymptote depending on if it gets crossed out or not. If it gets crossed out, it's a whole, like this one was. If there's nothing left after you cross out, you get all your wholes, then there's no asymptotes. Vertical asymptotes, that is. Okay, slant asymptotes. So remember, go back here. For slant asymptotes, if you have a horizontal asymptote, then there's no slant asymptote, but this time we did not have a horizontal asymptote, so we have this scenario. So we're going to have to do synthetic division or long division, so let's see which one we'll have to do. Now, since this is a 1x plus 3, we can do synthetic. So I'm going to write SA here so you know in my notes this is where it's coming from. So that's where you take the opposite of this bottom, so x plus 3, you're actually dividing by the -3. And then you take the coefficients of the top stuff, which is 1, 10, and 21, and put it in here. Then synthetic division says you carry that 1 down, multiply, and get -3. Then add 10 plus -3 is 7. Then multiply the -3 times 7 is -21. And then 21 plus -21 is 0. If you get 0 here, that means there's no remainder. So then my slant asymptote is x plus 7. And it's x to the first because we started with x squared, and then when you divide, it bumps it down a degree. So my slant asymptote is y equals x plus 7. And again, tomorrow we'll talk about what that means on the graph, but that just means when I graph this line, it's one of my asymptotes that it gets closer and closer to, but never touches. Now, you do notice that that x plus 7 was in the numerator, so if everything in the bottom cancels, then whatever's left in the numerator is your slant asymptote. Just FYI, that doesn't always happen where the bottom cancels too, like that. So that's why I didn't want you to get too used to that, but I did show you how to do the synthetic division. All right, x-intercept. So remember, x-intercept means that we use the factored form, plug in 0 for y, and only set the numerator equal to 0, then solve for x. Okay, so I take the numerator and I'm going to take the factored form. And you only take what's left over because this won't work. If you set x plus 3 equal to 0, you get x equals -3, but that was a whole, so it can't be your x-intercept. So you only set what's left after you cancel in the numerator what's left equal to 0. So then this would be x equals -7. So then that would be -7, 0 when you write it as an ordered pair. Okay, then you go to the y-intercept. Okay, y-intercept is when you plug in 0 for x, and this is the one where I said you should go back to the original form and plug in 0 for the x's. So I would do 0 squared plus 10 times 0 plus 21 all over 0 plus 3. Well, your zeros all go away. 10 times 0 is 0. 0 plus 3 is just 3. So 21 divided by 3 gives you 7. But when you write it as an ordered pair, that would be 0, 7. Okay? And then you filled in all your blanks. All right, so go ahead and pause it and try example 3, and then unpause it and try and see how you did. All right, so let's see how you did. Horizontal asymptote, the degrees are the same, so x squared and x squared, so that means that's the scenario where you take the leading coefficient over the other leading coefficient. So on this one, we have 1x squared and 1x squared, so 1 divided by 1 is y equals 1 is your horizontal asymptote. Okay, now let's factor to see if we have any holes. So x squared minus 1 should have been x plus 1, x minus 1. But the x squared plus 3 cannot be factored that way because it's not minus and you can't square root 3. So you cannot factor that. Okay, and then nothing's going to cancel, so there's no holes. And if we find the restrictions, we need to set x squared plus 3 equal to 0 to solve. So we would minus 3 and get x squared equals -3. Then we would square root the x squared to get that over there. And this is not a real solution. So there's no restrictions. So if there's no restrictions, that means that there's no holes or no vertical asymptotes. Okay? Slant asymptote. There's not a slant asymptote either because there was a horizontal asymptote. So there can't be a slant asymptote if there's a horizontal asymptote. So then now I just need to check the x-intercept. So if you go back, remember that means you set the numerator, and you might as well do the factored numerator, equal to 0. So you would have to set each parenthesis equal to 0 to solve for your intercepts. And if you did that, you would get -1 and +1. But you have to write those as two separate points because those are two separate points where it crosses the x-axis. It crosses at -1, 0, and it crosses at 1, 0. Then if we do our y-intercept, remember that means you go back to the original and plug in 0 for the x's. So if I did 0 squared and 0 squared, that's just 0. So you're left with -1/3, which is -1/3. So as an ordered pair, that's 0, -1/3. Okay, so this one was special in that there were no restrictions. When you set x² + 3 equal to 0 and try and solve for x, you get an imaginary number, which you can't graph an imaginary number. So that's why there were no restrictions. So when there's no restrictions, that means you can't have holes or vertical asymptotes. You only can have holes and vertical asymptotes when you have restrictions. And the restrictions that end up getting canceled out, those are holes, and the restrictions that are left over after you get rid of your holes, those are the vertical asymptotes. Okay? All right, so then try the worksheet, section 7, worksheet number 1. There's 2 problems, and see how you do on that.